Lots of variations on how to build a clock for Little Shop of Horrors. I want to show you what we did using a small DC motor and a pulse width modulation controller. So here's 0% and it can go all the way up to 100%. This particular motor is with the gearbox is rated at 10 RPM, so that's a full 10 RPM. My son, who's an electrical engineer, was also in the pit playing keyboard, and he wanted to add this little feature. You notice the red LED right here. That comes on when the clock is running. As it slows down, it does fade, but then it goes out when the clock stops. And that's how the pit band coordinated the tick-tock vamping music. So this is the simple construction. Again, the pulse width modulation controller and an LED with a 1K ohm resistor, which you could obviously skip. And obviously you need to make the wires longer, but for this demo I made it this way. I'm using Wago connectors. Are really nice. They just flip down and come down on the wire to hold it in place. So here's the motor and a gearbox. Again, this is rated at 10 RPM. I'll put a link in the description to these motors. They have many different ratings, down to I think 3 RPM all the way up to a couple hundred RPM or so. So this is sort of a combo of Brilliant and kludgy with the wood, but I'll show you how it works. Here's the pulse width modulation controller I used. Here's the electric motor I used. I got the 10 RPM version. So as with any of the simple AA battery clocks, there's a little knob here that can be moved and changes the time. So all I did was, I wanted to not directly couple the motor to this knob. So I took some peel and stick backed Velcro hook and loop, and I took the loop portion and cut it to this diameter and stuck it on this knob. Then on the end of the motor shaft is the hook portion. That effectively uncouples that slightly and gives a little forgiveness if I don't have that shaft perfectly centered on this knob. I want to say a bit about the controller. I used just a wall wart. I think you could probably use USB because it allows a range of DC input. Put the power to this pair of lugs, and then my output to the clock went here. If for some reason you want to run it in reverse, you just need to interchange these two. So if you really got fancy, you could put in a crossover switch that you could do that. But what we did was ran the clock fairly fast, and then as you approach the target time, slowed it down. So we'd run it pretty quick. If I want to stop at 1, I just slow it down. Let's try that again. We run it fairly quickly. Coming up on 2 o'clock, we slow it down, slow it down, slow it down, slow it down, and 2 o'clock. Okay, this is the part that's truly not high-tech at all. I just used a piece of Luan because it would flex a bit. Screwed it onto a piece of plywood, and there you see the motor stood off from the plywood. These are 3mm 50 pitch screws that go into the mounting holes on actually the gearbox. Short section of threaded rod, again 3mm 50 pitch, and then I cut a piece of plastic, put a jam nut on it, and super glued that threaded rod into this piece of plastic, super glued the hook portion of the Velcro onto that, and that made it up with the loop portion of Velcro that you see on that time adjustment knob just above the battery. So again, that allowed a little bit of forgiveness as this rotated. I'll show you. So there it's spinning. You can kind of see it speed it up. Ironically, to adjust the time clockwise, this has to spin counterclockwise. So if you're not careful, it'll unscrew itself. So I did have to use super glue to seal up that threaded rod into the shaft of the motor. One final note. Obviously the length of that threaded rod is significant because you want this to engage with the time adjustment knob. So that's critical how long you have that. But also you can make some fine tuning with the length of these standoff screws. Add more washers to effectively move that down tighter onto the knob, or back off the screws so that it's further away. You'll just have to fine tune that. It's got to be fairly snug, otherwise it'll spin out. If it's too tight, there's a little flex in the Luan, so it'd be hard to get it really too tight. Tighter is better. And it's just that simple.